Hello guys, my name is Mohit and I am an IIT Kharagpur graduate specializing in data analytics. I have worked with numerous product-based companies and I teach Excel, SQL, and Tableau in my YouTube channel named Learn Analytics with Mohit. Before watching my videos, I will request you all to please like, comment, and share my videos and subscribe to my channel as this will motivate me more to make future videos. So guys, welcome back to my YouTube channel. आप सभी का बहुत बहुत स्वागत है मेरे YouTube channel में. For old users, welcome again, and for new users, welcome for the first time. Today, we are going to learn SQL intermediate like unions and joins. Some videos will be on SQL cheat sheet, order of execution of SQL queries, interview questions to practice from DataLemur, LeetCode, and Strata Scratch. Lastly, I will also post SQL questions asked in different companies like MPL, Cars24, Whitehat JR, Zomato, Zepto, EXL, etc. If you find my videos helpful, don't forget to hit the like button and subscribe to my channel. Alright, so let's get started with SQL Intermediate and work our way up.
So, in this slide we will learn about SQL joins. So, SQL joins allow you to combine rows from multiple tables based on a related column. So, joins basically merges two data sets on a particular column, on a single column, and union merges rows or records. So joins basically merges columns, adds columns, whereas unions merges records, rows. In the following slides, you will encounter a detailed explanation of each type of SQL joins with syntax, examples, use cases, and a cheat sheet. Moving to the next slide, we have inner join. Description: returns only the rows where there is a match in both tables. So whenever a SQL query sees that system sees that there is a match in both tables, it will return those values. Let's say, for example, in the left table we have 1, 2, 3, or let's say 1, 1, 2, 3 record, and the right table we have 1, 2, 3. So 1 will match with 1, 1 will again match with 1. So 2 rows will be retrieved for 1, 2 will match with 2, 3 will match with 3. So in total 2, 3 and 4 records will be retrieved because we have all the matches in both the tables 1, 2, 3 and 1, 2, 3. This is the syntax and this is the example. Orders ID, customer name, from orders table inner join customers on or customer ID we are joining. Only orders with a matching customer will be shown. Use inner join when you only need data that exists in both tables. Example, find customers who placed orders. Left join returns all the rows from the left table and the matching rows from the right table. We rows with no match in the right table will show no. Let's for example, in the left table we have ID 1, 2, 3, 4, 5. In the right table we have 1, 2, 3. So 1, 2, 3 will match with 1, 2, 3. This will be the matching rows, or that will come from inner join, and 4, 5 will have null values in the right table when we join it. This is the syntax, and for example we have customer name, order ID, from customer left join orders on customer ID we are joining. Result: all customers are listed and orders will be null for customers who haven't placed any order. Use left join to find data in the left table with or without matching data in the right table. Example, customer without orders. Right join is same to left join. Right returns all the rows from the right table and the matching rows from the left table. Rows with no match in the left table will show null. Example, similar example we can see. Use right join when you need all data from the right table regardless of matches in the left table. Next slide. Full join returns rows where there is a match in either table. Nulls are returned for unmatched rows in either table. Example, we have same example includes all customer and orders even if they are mismatches. Use full join to find all data across both tables including unmatched rows. Example, all customers and orders including gaps. Cross join produces a Cartesian product pairing every row from the first table with every row from the second table. Let's say in the left table we have 1, 2, 3, 4, 5. In the right table we have 1, 2, 3. So 5 into 3, 15 rows will be returned in the case of Cartesian product. That is, it creates a one-to-many relationship for each of the values in the left table. Useful for testing or creating combination. Example, product store pairs or size color combinations. Joins a table with itself using an alias to differentiate the two instances. This is a self-join. Joining a table with itself. Example, find employees and their managers from the same table. This is a very important SQL question asked in numerous interviews. Select E1.employee name as employee, E2.employee name as manager from employees E1, inner join employees E2 on E1.manager ID equal to E2.employee ID. Comparing rows within the same table, example hierarchical relationships. Now this is a cheat sheet for SQL joins. Inner join rows with matches in both tables. Left table, left join all rows from the left table, matches from the right table. Right join all rows from the right table and matches from the left table. Full join all rows from both tables including unmatched rows. Cartesian product of both tables of all combinations. Cross join, self join, table join itself. Sample SQL queries with different types of joins for inner join. Retrieve employees who have salaries higher than the average salary in their department. So first we will calculate average salary in the department. Select average salary from employees where department ID equal to E.department ID. And here we have a condition where E.salary, we want salary higher than the average salary. So average salary is in the subquery and E.salary is the outer query. In the outer query we have employee details such as employee name, employee salary, department name. For employees E, inner join department D on E.department ID equal to D.department ID where E.salary greater than the subquery. Fetch products that have been sold at least 5 different stores. 5 different stores, so we are using having count distinct store ID as greater than or equal to 5. Grouping it by product name. In the select query we have product name and count distinct store ID as store count. From products we are joining it with sales on product ID. Find customers who have purchased all available products. So for purchasing all available products, here we have having count distinct o.orders. Product ID equal to select count star from products. That is selecting all the products from the products table. And we have select query customer name from customer C table, inner join orders table joining with customer ID, inner join products table joining with product ID. Retrieve the top 3 employees in each department based on their salaries. So first we need top 3 employees in each department. So select employee ID. So for this we have this one. Select employee ID, row number or partition by department ID, order by salary descending. As rank from employees, as ranked employees is the alias. Ranked employees is the alias for this subquery. Where rank less than equal to 3, select employee. From this table where rank less than equal to 3. So it will select those employees, top 3 employees it will select. Now in the outer query we have employee details like name, employee salary, employee department name and joining it with departments and E.employee ID equal to select employee ID. Display pairs of customers who ordered the same product on the same day. Now moving to left join question and answer, list employees who don't have managers. Select E.name from employees E, left join employees M on E.manager ID equal to M.employee ID, where M.employee ID is null. Find products that have been sold is join with product table, left join sales table, where sales.product ID is null. Retrieve customers who place orders but have no payment information. Here the filter will be where P.payment ID is null. Display employees along with the assigned project, including those without left join projects on product ID will be joining. List students who have registered but not enrolled in any courses, where E.course ID is null. This will be the filter. And left join we are doing and students left join enrollments. Now full join questions and answers. Find all customers and products even if there is no relationship between them. We can just join customers with products. All employees and products we can join on product ID, custom employees and products table. Show all orders in the shipments even if unmatched. We can join orders table with shipment table or order ID. Install regions and the respective sales even if unassociated. We can join region table with sales table or region ID. Self join, questions and answers. Identify employees working in the same department as the manager. In this case, employee name we have, manager name, e.employee ID, e.manager ID could be m.employee ID, and e.department ID could be m.department ID. Identify duplicate entries in an employee database. Here in this case, we have two employees where employee ID will be different but their name will be same. Find employees reporting to the same manager. Let me know in the comments if you have any doubts. Find employees reporting to the same manager. We can see the query. Try to solve it by yourself first and leave your answers in the comment. Let me see if you have better solution. I'll be happy to review it. Detect cycles in hierarchical employee structure. Select E1 employee as employee, E2 name as manager. For employee G1, inner employee G2 on E1 manager ID, E2 employee ID, where E2 manager ID equal to E1 employee ID. Compare employee salary with the same department to find salary gaps. Cross join, just create a schedule pairing every employee with every project. Join employee project with project. Cross join customer product combination, customer cross join products. All these are same. Generate address of all possible combination size and color. Join size and color. Cross join. Union. Union, the operator is used to combine the result cells of two or more select statements into a single result set, excluding duplicate rows. So union combines rows, whereas joins combines columns. Each select statement within the union must have the same number of columns, and the data types of columns must match. Example: customers US contains customers from the US. Customers Canada contains customers from Canada. Retrieve a unique list of all customers from both countries. In this case, we will use union. Merge use cases, merge datasets while ensuring no duplicates exist. Union all, we have retrieve all customers including duplicates. Union all we will use. Minus, retrieve employees who are not managers. In this case, we will use minus. Identify record that exists in one dataset but not in another. This is the use case. Intersect operator returns only the row that are present in both select statements. For example, retrieve customer row are present in both CS, US and Canada customer table. In this case, we will use intersect. Identify common record between datasets. Suppose you manage a database of products sold in the online store and physical online store, physical store tables. Retrieve all unique products sold either online or offline. In this case, we will use union. Retrieve all products sold both online and offline. Intersect. Retrieve products sold online but not offline. Minus. Retrieve all products sold online and offline including duplicate. Union all. And this is the cheat sheet. Union combines result set without duplicates. Union all combines result sets with duplicates. Minus subtracts one dataset from another. Intersect finds common rows between datasets. In the case of union, duplicates are removed. Minus also duplicates are removed. Intersect also duplicates are removed. But in the case of union all, duplicates are not removed. Use cases: in the case of union, merge datasets ensuring unique records. Union all, combine datasets retaining all records. Find record present in one dataset only. This is the use case for minus. And use case for intersect is identify shared records or similar records in multiple datasets. So that's all. It's for SQL Intermediate video. I hope you have learned important topics related to SQL Intermediate, joins and unions, when to use joins, when to use unions. We will use joins when we want to combine columns, and we will use unions when we want to combine rows. So happy learning, all the best. Please like my video, subscribe to my channel, and please comment on my videos if you have any doubts related to the topic or related to the query that I have shown you. If you have better solution to the queries, please post it in the comment section. I'll be happy to review it and I will get back soon. with answers in another video, or maybe in the comment. I can reply in the comment as well. So please like my video, subscribe to my channel. Thank you, happy learning, and all the best.